The overall goal of this protocol is to prepare and use an asymmetric-detection time-stretch optical microscopy system for label-free, high-contrast single-cell imaging in ultra-fast microfluidic flow.
The main advantage of ATOM is that it allows ultra-fast image capture with line scan rates of up to tens of megahertz, while enhancing the image contrast on the unlabeled cells.
ATOM enables complex morphological analysis of cellular and subcellular structures with an unsintered cell-based assays at up to 100,000 cells per second, which is not possible with standard flow cytometry.
To begin setting up the system, use a fiber collimator to couple a broadband femto or picosecond near IR pulsed laser to a single-mode dispersive optical fiber connected to an optical amplifier. Illuminate a transmission diffraction grating with the laser to produce a spectral shower. Orient the grating close to the litro configuration to maximize the diffraction efficiency. Configure a telescopic relay lens assembly in a 4F imaging system to direct the spectral shower onto the rear focal plane of an objective lens below a sample platform. Ensure that the spectral shower fills the rear aperture of the objective lens. Place another objective lens with a plane mirror at its rear aperture above the sample platform. Adjust the objective lenses until their focal planes overlap. Verify that the spectral shower double passes the image plane and follows the same path back.